Welcome to Introduction to CFD course. First we start with Introduction to Naval CFD. But before going to that, it is compulsory that first we understand what is CFD. So first few slides we will see what is CFD and major areas of CFD. So we will go to the next slide. Okay, in this slide we will see what is the full form of CFD. Some people will say that they can understand CFD, they know CFD. They will download some software in internet and do some meshing and as per tutorial and get a mesh and put in a solver like Fluent to go through some tutorial and they will come with some result. That is not CFD actually. That is CFD, but that is full form maybe colorful display. But coming to this computational fluid dynamics, we go through some steps. First we have some idea, then we'll go to physics, then we'll find a mathematical model for that and solving this mathematical model by different methods. Then finally we'll get some result that we have to interpret in a that should be agree with common sense. So what I'm trying to say here is that if you want to simulate a phenomena, first you should know what is your idea, what you want to find. You want to find only drag, only force, like a ship is coming, what is this resistance of the ship, or what is the thrust of the propeller. That is your idea, that is you want to measure that one. Then next step is to understand the physics of that, which all the physics are involved in that, whether it is easily you can derive by a partial differential equation, something like that. So if you find out a physics, then you can easily make a mathematical model. Okay, so you write down the equations. Then the question is that how to solve this equation. So we should have some numerical methods and all. Then after solving this, you should know why the pressure is here more, why this contour is behaving like this. So this kind of interpretation skills you have to develop. That should be agree with physics and common sense. Okay, so this type of method we have to go if you are working for a research organization, if you want to learn CFD, or if you want to show some good result, okay, you can go for colorful CFD. Okay, that is called colorful display. Okay, fine. Okay, in this slide we will see what is mathematical model. Okay, so I'll just ask one question. Which was created first, the universe? See, if universe was created first, then this every heavenly bodies were obeyed by what? Some people may say it is God Almighty or some kind of supreme power. No, actually, this is heavenly bodies were obeyed by some laws, some partial differential equations. So fine. So this earth or sun or moon all are moving and it is obeying some equations. So my question is, which one is created first? Maybe the order, the partial differential equation is maybe created first, and that's why this everything is obeying. So what I am trying to say here is that everything in this world is obeying some rule and regulations. So everything is moving in some particular order. So that's why once great scientist Einstein said, God never plays dice. Okay, and it is not random, completely random. It is going through some equations. So the order or the movement is some partial differential equation or PDE. To find the proper PDE is called mathematical model. Maybe a turbulence. You see, one turbulence is going on. Actually, we never learn completely about exact phenomenon of turbulence, how it will codify, make it as a PDE. But still, we are able to solve around 80 or 90% of the phenomena by solving some partial differential equations. Okay, now we got it. So we'll go to next slide. This slide we'll see why is CFD. See, all partial differential equations were written 100 years back. Then why CFD come recently? CFD may be just 20 years old. So the answer is CFD made possible by the digital computers. Digital computer and advancing in that their computational speed.
See, 1947, just 500 flops. Floating operation per second is possible, but now it is 20 teraflops. You maybe know mega, giga, tera, 10 raised to 3, 10 raised to 6, 10 raised to 9 teraflops. Now, many countries are already planning some petaflop systems. Now, people are already talking about extra scale. After peta, we say extra scale systems. So, because of this, we can solve this partial differential equation within small time frame. Previously, you see, if you want to predict tomorrow's weather, it may take 2-3 days. Then what is the use for that? So now the computer scenario is changed. Now the computer facilities are improved. So now we can solve very complicated things in a very short span of time. Okay, we'll go to the next slide. Okay, then the question is why we use CFD. Okay, so the question is very simple. Without CFD, you have to make a model and test it in wind tunnel or if it is water tunnel, whatever may. It is very cost effective. More cost effective means to create a model and test it like a ship and all. I'm working in the naval side, so it may take 1 year to 2 years to do all the tests. But in CFD, we can solve within 1 or 2 months all the simulations we can do. Another is that you need a full. You cannot do a full scale simulation because one ship may be 300 meter, so you cannot test it 300 meter ship in a tank. So you have to reduce that scale. Means length may be 5 to 7 meter. Similarly, so many affect wind, weather, so many explosions, so many weather conditions may affect your research. And another thing is that in CFD, you can explore the flow physics. I need a particular point, I need velocity, I need pressure. Everything we can visualize what is happening in the every side of the model or every where in the domain you can see, you can explore it. That is the best. And another thing is that cost effective. You need only one computer. To set a big facility, it may cost you crores of money, millions of dollars you have to spend. But it is very simple. With a computer, you can get all the results. Okay, we'll go to the next slide. In this slide, we'll see different areas, different fields where CFD is used extensively. First and foremost is aerospace industry. Many people in aerospace design engineers are using CFD in their design stage. Not only in design stage, in everywhere it is they are using. Evaluation stage, everywhere, because aerospace industry they can spend a lot of money for research, and also CFD is very much used over there. Automotive also recently last 10 years they are using, they make a shape like aerodynamic shape now they are using. And recently this biomedical where the flow is Reynolds number is less than 1 and all, in that area now people are using CFD very effectively. You can see the biomedical area, the eyes, cornea, the area also they are optimizing with tools. Another area is chemical processing field. Many research are going on in that area. So another people are using extensively like battery, etc. And chemical reaction, chemical processing, people are using CFD. And HVAC, that human ventilation adaptability areas, people are working how the AC works, etc. And another important area is hydraulics, dam braking, removing the shutter, time, how the flow will go, what is the velocity of the flow, everything will be predicted by CFD analysis nowadays. We'll go to the next slide. Another major area is marine field, marine propeller, ship. Nowadays, previously marine engineers or naval architects are not using CFD for their design, but now it is become compulsory. Classification societies are also agreeing CFD results. So in marine area, people are using CFD, and then oil and gas field. That is very important nowadays. Offshore structures are growing like anything now. So this field also CFD is extensively used, and of course power generation area also, electronics field, fan cooling, computer, all those areas where the fluid is there, means the in computer and high surveys how the flow is blowing into the proper areas decided by the fan and the speed. All those things can be designed by CFD. Another area, sports, when the swimmers goes on the drag, how much it will come, how can they reduce the drag, that everything can be designed by CFD. So okay, we'll go to the next slide.
Okay, now we see what is the objective of naval CFD. As we know that many experimental tests we have to do before building a ship. First is that towing tank test to find out total resistance. Another is simulation of the open water propeller characteristics. Then self-propulsion point, and also we'll check for cavitation characteristics. All the steps. Finally, we will do maneuvering test, seakeeping test, etc. So all these experimental tests we can do it by CFD. Now CFD is matured enough to give a very good result in the range of 5 to 3%. So 3 to 5%. That is very encouraging. So nowadays there is no need to do any kind of experimental test. So that is the objective of naval CFD. Whatever the results we are getting through experiment, we can produce by CFD. So we should learn CFD. It is very cost effective and very easy to model. Otherwise you have to spend a lot of money for making model, big facilities. The investment of that facilities may be in millions, etc. So with that we'll finish this naval CFD introduction. We'll go next session about little bit of mathematics to understanding the vector and tensor. Then we'll slowly go to the fluid dynamics equation, and then we'll see the discretization, etc. So finally we'll do how to solve partial differential equation and what is the post processing and how we'll get forces and thrust, etc. Okay, thank you.